Hello guys, good afternoon. Welcome to Physics Laboratory class online. Today we will be showing you how to perform experiment number 3, and experiment number 3 is about conservation of energy. Theoretically, the law of conservation of energy states that energy cannot be created nor destroyed, it can be only transferred or transformed to other forms of energy. In our experiment, we'll be dealing with potential energy, which is the energy of the object in its position. And then the second one is the kinetic energy, which is the energy of the object in motion. We will try to analyze the experiment in which how a potential energy is converted or transferred to kinetic energy, or vice versa. In this experiment, we'll be using the motion sensor. Okay, the motion sensor is used to measure the position or the vertical height and also the velocity of the object, in which the position will be used to measure the potential energy using the formula mvy, which is m is the mass of the object, g is acceleration due to gravity, and y is the position of the object. And then for the velocity, we'll be using the velocity or speed in computing for the kinetic energy. So the kinetic energy is simply 1/2 mv squared, in which m again is the mass of the object, and then v or the v squared is the square of the speed or the velocity of the object. Okay, so according to the equation, we'll be needing the m, which is the mass of the object. So in our case, we'll be using this plastic ball. So we need to compute or to measure the mass of this metal ball. Again, so this is the motion sensor. This is used to measure the velocity, also the vertical position of the vertical displacement of the object. We have again the GLX Explorer. So it stores or compute the values measured or sensed by the force sensor. And of course, we have the top loading balance. We will be using this to measure the mass of the plastic ball. So in that case, so we have the mass is 20.24. I'll be placing here the mass of the ball. So that is 20.24. That is in grams. But in our experiment, we'll be using kilograms. So we just need to multiply that by times 10 to the negative 3. So we have 20.23 times 10 to the negative 3. So now that is in kilograms. So we need to get the y, which is the position, and also the velocity. Then after that, we can compute now for the gravitational potential energy and the kinetic energy. And then after that, we need to compute for the percentage error. In this experiment, guys, we need to do 10 trials, but in our case, we will be showing you how to perform only the 3 trials, because the remaining 4 to 10, they have the same procedure with the 1, 2, 3 that I will be performing today. Okay, so the GLX is set to tables. Okay, this will be set to tables. Okay, the first column is set to position or the y, and then for the second column, this is set to velocity. So the position will be used to compute for the potential energy, and then the second column will be used as the velocity that will be used to compute for the kinetic energy. Again, for the potential energy, the formula is simply mgy, and then for the kinetic energy, the formula is 1/2 mv squared. Again, we want to show you that there is conservation of energy. So meaning whatever be the volume of the potential energy, that should be the same with the volume of the kinetic energy. Okay, they should have the same volume, because what happened is we just simply transferred the volume of the potential to kinetic or vice versa. So they should have the same volume. Okay, so to start, again, the volume of the mass of the ball is 20.23. So this will be constant. So all the data from trial 1 to trial, and your mass will be 20.23 times 10 to the negative 3. So what I will do is I will be placing, okay, I will press the play button here. Okay, I will place the plastic ball here, and then at any time I will drop the plastic ball there. Okay, stop the reading. And then my target is to actually the height from the force sensor to the floor, so that's 1.481. So usually the value of the potential and kinetic energy, they have the same value at the mid range, so that is around 0.6 to 0.8 meter. Okay, so I will just look at at the GLX, and then my target is to get the reading in which the position is on the 0.6 to 0.8. So that is on the mid-range. Okay. So I have here, so this is 5.40, this is 0.677, this is 0.824. So what I will do is I will just choose one reading here. But anyway guys, you can choose any. Okay, you can choose any from 0.540 or 0.67 to 0.989. So it depends on your choice, and your value of the gravitational potential energy and kinetic energy will be depending on your chosen data. Okay, in my case, I'll be choosing the 0.824. So the position is 0.824. I'll be placing here the 0.824. Okay, and then the final, or the velocity is 3.86. So this is 3.86. Okay, I'll be computing for the gravitational potential energy. Again, the formula is simply mgy. So the mass is 20.23 times -3 multiplied. So this is the mass. Acceleration due to gravity is 9.8 multiplied by the height, 0.824. Okay, so this is, okay, I choose 0.824. So this is 0.16. Gravitational potential energy is 0.16. And then for the kinetic energy, the formula is 0.5 times the mass, which is 20.23. Okay, multiplied by square of the velocity, 3.86 square. Okay, so this is 0.150709, or simply 0.15. So the kinetic energy here is 0.15. Okay, to compute for the percentage difference, so you just need to get the difference between the two divided by the average of the energies. Okay, so that is equal to 0.16 minus 0.15. Okay, all over the average of the two. So that's 0.16 plus 0.15 divided by 2. Okay, so the answer is this one, okay, multiplied by 100. So the difference is, so that's 6.45. Okay, meaning I did the experiment correctly at around 95.55 accuracy. Okay, so that's for the first table, or the first trial. Now I will be doing another trial. Okay, stop the, okay, now press the play button again. Now this is already, but before that I'll be setting here the ball. Okay, now this is reading now. Then at any time I can drop the ball here. Okay, stop the reading. Then I need to choose from the data given. Okay, I'm looking for the range at around 0.649, 0.796. So here, I have here 0.649, this is 0.796. I'll be choosing 0.796. So 0.796. And then, so that's the position, 0.796. Then the corresponding value of the velocity at that position is 3.79. So this is 3.79. Okay, the same thing. Okay, use the formula mgy to compute for the gravitational potential energy. So so that's 20.23. So this is the mass of the ball multiplied by acceleration due to gravity, 9.8, then multiplied by position, which is 0.796. So here the value is 0.1578, or to round, I need to round up this one to 2 decimal places, so 0.16 also. Okay, and then for the kinetic energy, so the formula is 0.5 multiplied by 20.23. Okay, multiplied by velocity. So this is 1/2 mv squared. Velocity is 3.79 square. Okay, so 0.145. 0.145. Okay, 2 decimal places. that's also 0.15. So this is 0.16, this is 0.15. Obviously, the answer will be 6.45 also. Okay, this is for the second trial. Now, for the third trial, okay, stop, and then, okay, press the play button. Anytime, I can release the ball. Okay, stop. Okay, now, here's the reading. I need to look at the okay, so this one is 0.657, this is 0.807. So I'll be using the second one. But anyway guys, you can also choose the first data, 0.657. But again, in my case, I'll be using the 0.807. So 0.807. And then the velocity at that position is 3.84. So this is 3.84. Okay, the same procedure. Let's compute for the gravitational potential energy. So mass, which is 20.23 multiplied by 9.8, which is acceleration due to gravity, times the position, which is 0.0807. So this one is 0.1991599. So this is also 0.16. And then for the velocity, so we'll be using the velocity to compute for the kinetic energy. So 0.5, 1 half times 20.23 exponent negative 3 multiplied by velocity square, 3.84 square. So the answer here is 0.1491 again. So this here is 0.15 also. So my error is also 6.55. It just, I think, just a coincidence that the value or for the gravitational potential energy is 0.16 and also for the kinetic that's 0.15. But sometimes you can get different value. But in our case, in my experiment, these are the data I collected. Okay, I will not be doing the 4, 5, 6, 7, 8, 9, and 10 because the procedure will be the same. So what we will be doing is we will just send you the values for y and also the values for velocity, and then you're the one who will be computing for the gravitational potential energy, for the kinetic energy, and also for the percentage difference. Okay, again, what we want to show you in this experiment is the conservation of energy, in which the potential energy is equal to the kinetic energy. Okay, and that can be verified by computing the percent error or the percentage difference, in which the percent difference or the percent error should be less than 10. Okay, so thank you so much guys.